Okay. So it's a load balancer. And this thing is same to all public cloud. Are you getting me? This is the traffic is receiving. And this is the mechanism. These are server or the instances or database. You understand me? You understand me? Or network, depends on the kind of load balancer you are using. So let's assume that this is an application load balancer. If it is an application load balancer, it takes the firm response from the internet. Are you getting me? And look at these servers. If those applications that they are requesting for is in this server, if they are there, the one that can accept this the traffic, it will collect the traffic. Then after collecting the traffic, you understand me? So regularly, it checks the health status of these servers or instances to see if they are available to receive traffic. You understand me? Check the health status of this application to see if they are available to receive traffic. If they are available, it sends traffic there. If there's a fault, automatically you remove, you isolate the system that has fault so that the remaining two can collect instance. You understand me? Even at the end of the day, we now have only one that is still working. You understand me? Until the last one goes off. But most times, before it gets to that point, you as an infrastructure engineer, you should know that you should quickly fix it. You understand me? And make sure that the three are receiving traffic. This is just the simple mechanism of illustrating a load balancer. So every load balancer we're going to be doing is this simple, and this is the simple concept, and it cut across all public cloud. Understand me? Cut across everything. This is load balancer for you. So I believe, do you have any question?
No, I don't have a question. I really understood the
this guy have left.
Concept.
Okay, you've understood the concept. Okay, now let's demonstrate it. Or should we wait for the other thing to go? Okay, let's also explain. Let's also explain elastic is not let's explain elastic auto scaling. Understand me? So this is why most times I like to have a one-on-one class with my students, because you will enjoy what we are doing here. Okay, let's assume this is you maybe you have a system like this. You understand me? These are the three systems. And the traffic, the way we explained just now, we can even use this one to also explain it. We can design these instances at the back to spin up instances. You understand me? For example, if the load, we can say, okay, this system, immediately these servers, I'm using this particular, you can see the difference between the objects. Okay, let's assume that this is our infrastructure. And presently we are using three. So we can design it that, please, when each of these servers, these three servers are up to 75% or 70%, spin up extra two, one to the left and one to the right. So immediately the server is up to 2, it will communicate with the CloudWatch. Are you getting me? The CloudWatch will automatically trigger this. Then if it triggers it, what will happen is this: automatically the load balancer will extend. Are you getting me?
To it.
And connect to it. And connect to it. All these things will happen without your knowledge. Meanwhile, these instances that are not connected yet, you are not paying for it. You only pay
until they are
connected. Until they are connected. Understand me? So immediately these systems are 50%. All of them are 70%. Automatically, these two servers will spin. Immediately it spin, they will be attached to the load balancer. the load balancer will keep sending traffic there. You understand me? But immediately you also configure it that if the system is below 70% for 3 minutes or 2 minutes, shut down those extra. So what am I trying to say is this? Depends on how you design your instances, how many instances you want to spin for auto scaling. For example, now this is 5 already. And you understand me? You started with 3. You say you should scale to 2. You can say you should scale to 10. But in that 10, you can say in every 70% on all of them. Are you getting me? You should be increasing by 2. Immediately this one is 70%, this one is 70%, automatically another one will spin up. But immediately the load, this one is, okay, assuming this one is 70%, this one is 70%, this is 70%, automatically this one now goes to 60%. Are you getting me? For 10 minutes, what will happen to this instance?
It will cut off.
Good. This instance will shut down automatically. Then this 3 will not be working. Meanwhile, for this instance to come up, you have to set up an image. What do I mean by image? You have to set up a storage unit that will save the same application that is here, and here. You understand me? We save it in a storage format. That storage is called EBS, Elastic Block Storage. You will save the operating system, the application, and save it in Elastic Block Storage, so that when this one wants to spin, it will only spin from that image that you already saved. So for auto scaling to work, you must first of all configure your storage system. It's like an hard drive. You say, okay, this hard drive, this is where you are going to be spinning from, because these things will not spin up on their own, even though you configure the auto scaling. Because if they are going to spin up, they must spin up an application that is similar and exact this, so that it can fit into this load balancer. You understand me? And for that to be possible, automatically it means that this already running instance are the same application and everything. So that is why you take a snapshot. If it's a database, you take a snapshot. You understand me? So that is it. So that is just the different. That's the meaning of automatic auto scaling, and elastic load balancer. So this is just a simple illustration. So from there, we will now go into block storage. I've talked about block storage before. Block storage, we have 2 types of storage. We have how many types of storage systems? More than, I think we have basically 3 types. But if you now add database to it, it makes it 4. That 3 type, if you expand that 3 type, it becomes 5. You understand me? So we have EBS, which is elastic block storage. That one is like a normal hard drive. So whenever a system wants to come up, you must put a hard drive to it, because that is where you store your operating system, your information. Then after